Hi folks, it's me Alex. There wasn't a devlog last week because I was on holiday in Malta learning to scuba dive, which was an amazing experience, but if you were looking out for one, sorry, sometimes you need to get on holiday. Today I'll talk about something that I really enjoy doing, and that is procedural generation. Specifically, I'll talk about how we generate the world and islands in the game. And this devlog will be a little bit different because I'll use slides from a talk I've done at Roguelike Celebration and Everything Procedural, some industry conferences. So, why procedural generation? Well, it gives you a lot of replayability, but high upfront cost and effort in all the code you have to write. And it also helps give the world a sense it is not there for the player's sake, but on its own terms. It gives the world consistency and a set of rules that everything obeys. It's also really fun to do, especially as a programmer, because you have to do pattern thinking, like you have to see how something is constructed, and from that you have to define the patterns that the generation is actually using to create the level or the content that the player is exploring. And it's not the same as generative AI. With procedural generation, you can reason about why the output is actually doing what it's doing. You know the algorithm. And it's not this black box that generative AI and LLMs are. Generative AI is very mushy in comparison, and it's hard to work towards a specific goal and reason about why the generator is making the output that it actually is. And yeah, I thought a good topic to start with when it comes to the generation is in the game is how we create the islands and how we went from green blobs with boxes for houses to the sprawling harbor cities we have now. Something that hasn't changed since I started on the game is that we generate the world in these cells and what I call chunks. And chunks are for the land, like the islands that you see in the game, and each cell is either land or sea. And a chunk is basically just the 3D model that makes up the island. In the first iteration of the generation, I used multiple layers of Perlin noise, which is this endlessly tiling, soft-looking texture, and a common core building block of procedural generation. These were added together to form what's called a height map. That's how high the ground is at a given point. And I used two scales of noise. One controlled what cells were land, and another was for the land contours inside each cell. This gave fairly good looking islands and continents, but you got this sort of like Swiss cheese thing where there are lakes very close to the coastline. And that also turned out to be a gameplay issue because the player would sometimes spawn inside of one of these lakes, which was an instant game over and not very fun to encounter. Another issue is that it was impossible to adjust the difficulty. Sometimes the player would spawn in the middle of the ocean on a little tiny archipelago of islands, and that would be so far to the next landmass that the level was just impossible to play. So for the next version of the generation, I redesigned the whole thing. This is also where the game changed from being inspired by the Age of Exploration and went more into the Lovecraftian themes. I turned the whole world into a circle where the player starts at the edge with the goal of getting to the center, and to get to the center of the world where the Great Rift is, and try to figure out why the world is tearing itself apart. This generation was also a lot easier to tweak because I could say specifically, oh, I want like this amount of rift bands, and I want each island zone to be these dimensions, and I want this distance between each harbor being generated inside of them. So the parameters for the world generation was much more tied into gameplay than being like, where will all these layers of noise create land? So much faster to tweak. For generating the contours of islands, I had some specific goals in mind for the new generation. There needed to be a clearer boundary between land and sea, and instead of having land determine where harbors could be spawned, harbors would determine where there was land. This is because harbors are more important for gameplay, and the distance between harbors is important for the overall pacing and difficulty. Harbor cells are always connected with at least one edge to a water cell as well, so the player can't get stuck in lakes anymore, which was also really important. To generate the island perimeter, the most important factor is the size of the harbor. So, for example, a village will be on a small island and a city will be on a larger island. First, the algorithm picks an access corridor to the harbor so the player can access it, and we won't spawn any land cells there. Then we pick a random cell next to the harbor and make that land, and then we sort of like just grow land cells out from those cells that have already been placed, where we favor cells close to the harbor first. This is to make sure we don't get these long, spindly islands that would be annoying to sail around. When all the land cells have been placed, we change the cells around the island to belong to the coastal water biome. And this is to both give a different look when close to land, but also coastal water is easier to be in than ocean and deep ocean biomes, so this also helps vary the difficulty and encourage the player to first stick close to land, and then once they have leveled up a bit, move further out into the world. To create a clear separation between land and sea and also have a natural looking coastline, I use something called splines, which is a set of points that are connected together with a soft curve using math. First, the algorithm finds points on the edges between each of the land cells and connects those border points with splines. The splines can't go outside the cell that they belong to, so that's why we don't have weird intersections between the splines in each cell. And the splines that meet at cell edges share what's called tangent directions, and that's how we ensure that they have continuity. That's just math speaks for saying that they smoothly connect with each other, so you can see the seams and know where the cells meet. Each point in the 3D model that makes up the island gets their height based on the distance and direction to the spline. So if it's on the left side of the spline, it's water, and if it's to the right side, it's land. The distance to the spline determines the height, and depth actually drops off faster than if it's land, and that is to make sure that the player doesn't get stuck when sailing close to islands, so it's purely for gameplay reasons. Texturing the islands is done with a shader, which is a small program that runs on the graphics card. We use the position of each point in the 3D model to dictate the overall scaling of the texture, that is, how often it repeats. And the height is used to control where beach and grass meet, and this is something we can also tweak in the shader's parameters, as you can see here. For harbors, we have a different cobblestone texture, and that is controlled with a separate mask texture. This mask is being sent into the shader based on where there are streets and houses placed by the rest of the system. And I'll go into in a separate post how that is done, because it's kind of like builds on top of this and it's more complex, but it's also really cool how it works. All right. That's all I had for now. Thanks for listening. This time around, I'm trying out a different setup. So let me know if the quality is okay. Yeah, I got tired of having the microphone in front of me, so I hope the audio quality is still good. But I also found out I could add filters in OBS to get better microphone output. So I think it's actually going to be better. Let me know. And yeah, of course, if you haven't, the demo for Sea of Rifts is out on Steam. And that's also where you can wishlist the game and follow us to get updates about upcoming playtests. Safe wins.